Hi, I'm Richard Duvall. I'm an EDA marketing manager for RF products, and I've been at Keysight 5 years. And before that, I spent over 20 years in test and measurement industries and video networking.
Roberto, how about you?
Awesome. Thank you, Judy. I've been in the test and measurement space for over 25 years. And for the last 2 years, I've joined Keysight. I've been leading the design engineering software marketing team, which includes EDA high speed as well as RF. I also thought about saying a little bit of my fun stuff about me. So then I wrote a couple of illustrated children's book, and I'm a huge fan of Star Trek. So super huge fan.
That's why we're friends. We're fellow Trekkies.
Oh, that's cool.
I love it. Okay, well, gentlemen, I don't know that you've been paying attention so much to my podcast lately, but I'm probably 5 or 6 podcasts in talking to a variety of different people that are talking about the way AI, LLMs, and machine learning are going to really transform design engineering workflow across many segments. And so I know both from your high-speed digital side of EDA at Keysight and the RF, there's a lot to talk about. So it looks like we're about to have a huge tipping point in this industry. That's what I'm observing. And so these tools are leveraging this technology, but it's very early days. So what do you think's coming next as we lean into 2025?
Well, Judy, that's a really good point of discussion because, AI-assisted tools automate complex design tasks, and they can reduce the time and the effort required for things like circuit design, layout optimization, verification, all of the tasks that we're doing at the moment. But we can't incorporate AI into a workflow unless we can automate the workflow. So I'll give you an example of some of the things that we are up to in ADS 2025. We're introducing a whole set of Python APIs. And, the idea is to unlock the platform. A lot of things that we do are preset or have limits. But the idea about unlocking the platform makes ADS easier to orchestrate and makes the tools customizable and easy to integrate. And so that's really just step one, which is open connected workflows, which are really enabled with Python APIs and Python scripting language. And really, we're following our customers' lead. They've told us they don't want to be locked into one EDA platform. They really want to be able to choose best-in-class workflow elements and integrate them together. And so for us, this is just the beginning.
We talk about heterogeneous integration when it comes to chips and packaging and all of that, but it is absolutely a tool when it comes to the technology stack that design engineers want to be able to use. And you're right, they want that flexibility. So I'm happy to see that the industry at large is leaning into that trend. So on the RF subject, I had a little stint of my life, mostly around RF PCBs. And, IoT is everywhere. And along with AI and LLMs and machine learning, we're always pushing um, the we're always pushing the frequency, and now we're moving towards 5G and 6G. So, can you give maybe a more tangible example of how that workflow gets stitched together?
Well, I've got two really good examples of how, we see AI being used as an engineering assistant. So, in this advanced 5G on the path to 6G trend that we're on, um, one example is, 6G will use AI in network operations to overcome path loss and improve throughput. So, for the physical layer research that's going on, our system design product is being used to do two things at the moment: generate training data sets that are reliable real world 6G faded waveforms for AI ML algorithms. And the second is to validate AI ML algorithms under real world environments to quantify design margin and performance. So
Hmm.
that's, that there's a small group of people doing that. Another good example, this is something we're introducing in the launch event in December that I'll talk more about in ADS. So we've come out with an AI enhanced load pool toolkit, and load pool is a big issue because of all the beamforming and phased arrays, the effect they have on power amplifiers. So this load pool toolkit creates advanced simulation models using artificial neural networks, and it integrates measured data from lots of different sources that are in different formats. And then it extracts the simulation model and validates it in just a few minutes. So we've got a great video and an app note on this topic that we'll link in the podcast.
Okay, good. And I'll be interested in seeing that because the other thing I'm hearing is about how to make sure that with these LLMs, like we're not pulling the data from the internet. And I'm sure that I know Keysight, and I'm sure that it'll be really interesting to talk about how exactly that's done. And, seeing things go from maybe weeks to minutes is truly stunning. And I'm seeing it all around me right now. So, Roberto, what's happening with the high speed digital side of technology that you're overseeing?
Yeah, no, this is a really good question, Judy. One of the things that we talk often with AI, and I don't see people talk a lot about this, is it's really AI infrastructure. If you think about the for AI to work, it requires a lot of computing power to be executed, right? And where does it happen? Data centers, right? This is all about data centers. Now, if you think about how data centers they operate and they work, and this is it's a computer. It's a computer. So you have a CPU, you have GPU, you have an AI IO hub in it to talk like USB, DDR, PCIe. So, but think about that. You're gonna have hundreds of these compute units inside the data center, right? And it doesn't get really scalable. If anytime when you need to run a new AI model, a new AI workload on the data centers, just let's go one of those. Back in my days, it was like a store that I don't know that it exists in California. Well, it was California. Fry's used to be a large technology stores, right? I would go to Fry's, buy the board, a CPU, just put stuff
Right.
together. You cannot do that kind of stuff with data centers. And if you're gonna put a server together for every new model you gotta put in there, there's no physical space. Computers there are kind of large. So what
Mm-hmm.
people decided to do with AI is that they started to build this dedicated AI chips. And if you think about a GPU is kind of a dedicated chip on itself. It's a
Mm-hmm.
chip that does something really well, like for example on the math lab. So think about you start in the past you had the motherboard, CPU, GPU, put everything together, large computer. Fast forward to today, you have like a what people call a system on a chip. You put all of these pieces together in a very tiny space, becomes system on a chip. Now, what is about system on a chip? Well, you design it's a large monolithic thing. You have the CPU block, you have the CPU block, the CPU, GPU, IO hub, um, and then you make this device, you put it in the data center. If you need to, let's say you need more GPUs, what do you have to do? Well, you have to start the whole process again, build a new system, a new system on a package, And this whole thing takes time. So do you think this is scalable? What are your thoughts? For you to be redoing this thing all the time? No, right?
Mm-mm.
So there's something that happened in the last couple of years that is not really a new technology. It's chiplets. So imagine we have these common blocks: the CPU, the GPU, I/O hub. You make this monolithic uh, device. But I imagine that you break this into smaller components. So then you have a chiplet for the CPU, a chiplet for the GPU, a chiplet for the I/O hub, and then you put some very high speed interconnect in between them. So then you can have the data flowing back and forth. So instead of this monolithic design, you have now what people call the heterogeneous design.
Uh-huh.
You have all the different packs together, these different chiplets together, and interconnect like UCIe or a bunch of wires, BOW, to send data back and forth. And then when you need to let's say you need more GPUs, all you do, well, let me put another block of GPUs in here. So it's very scalable. The other interesting thing about, and you might know this, the other interesting part about heterogeneous design is that you don't need to have all of these blocks using the same technology. Let's say maybe the USB controller, you're using 5 nanometers, 7 nanometers, which is very well known technology. It's a cheap technology. You do that. Perhaps for the GPU, you use 3 nanometer. You need pack a bunch of transistors there. So you have the ability to really cost optimize your design with this different technologies for the different block that you need. Now it makes it really hard for like a designer, for example, to design all these different things together if they don't have the right tools in place.
Right.
And this is one of the things that Keysight is really keen on. Try to figure out ways to help the designers to do their jobs in a faster, easier way. So I think you and I talked a couple of months ago. We released a really cool technology that was introduced in the Keysight EDA, Chiplet Phi Designer. So
Uh-huh.
this is part of the ADS software, and it's an amazing tool that really helps the designers uh, incorporate chiplets into their new designs.
Around that time we were talking, Roberto, I had the chance to make a chiplet podcast with Steven Slater, who is on product manager on your team, and it was fascinating. But I also noticed that he said, which is sort of what we're talking about now, like we're definitely making inroads, but the days are still early. So um, I kind of want to throw a question here we didn't talk about ahead of time, which is how do we manage what's here now and be prepared to move into this future of technology? I mean, if you're a design engineer, what things should you be doing or learning or adopting right now
Well,
that
I
you
think
could
yeah,
go ahead?
in my head, I think you should not be afraid of automation. You should really embrace automation in this new age of AI assisted tools. I mentioned the Keysight Triplet Phi Designer, but I failed to say
Hmm.
that one of the good things about you really embracing these automation tools is that you have a company like Keysight that has decades of measurement science, many years of design expertise. We participate earlier on into several industry bodies like the Chiplet UCIe organization,
Hmm.
TRIDEC for DVR, and as we participate in those things, we have not just the opportunity to influence, given our background in the measurement side, but we also learn firsthand what is changing. So then we can
Hmm.
anticipate how the marketing is changing, and then we can implement this functionality in our solutions. So in this next generation of our EDA software, the 2025 version, we actually introduced the Buncha W support for the Triple Connect. We are also introducing additional analysis for crosstalk. That also includes support for quaternary clock QDR, which if you have all these tools, there's all this functionalities in the tool. This means that the designers can just click a couple of button and do the analysis. They don't have to be doing all of this stuff by themselves manually. So this is one of the things I think people need to be really open to is embrace automation. It's here to help.
I since I've been doing this series on AI, I've had some funny conversations on LinkedIn, and there's always the old stodgy engineers that are outstanding engineers, but they'll push back and say, yeah, it can never do what an engineer. But the message I'm hearing over and over again, and I hear from actually you both now, is that it is AI assisted. And I like the word a lot of people are using in their marketing materials is AI co-pilot. But everyone is saying right now, it helps take some of the tedious stuff out of your design workflow and leaves you in the driver's seat to do the really critical engineering judgment and use your intuition, so it actually frees your hands up a little bit. Is that your sense of what, Keysight is leaning into in this regard?
Yeah, and you know what? Can I use perhaps I can't help, but I'm going to use an example from Star Trek. I guess I have. Here's the thing: when I was younger, I used to watch those movies, and I said, "No, this is not real." You see, like a teenager, somebody in the years designing robots and designing very sophisticated machines, and then I would say, "No, this is not possible. This is never going to happen." This is what really is AI assisted. These people, they're not more intelligent than us today, the people from Star Trek. It's just that they had the right tools that are allowing
Absolutely.
somebody with
Mhm.
very young age to do things. AI is not doing the job for that person. The person has to say, computer, can you please create a circuit design that does A, B, C, D, and does this other part? It give you a really fast, quick start. It abstracts the beginning, so then you don't have to start from a blank page or where do I go from here? So I think that this is now I actually when I look back those movies and series, say, hey, you know what, I was completely wrong. I failed to see the future, and see that this is actually possible, with the right tools.
Yeah.
Those things are possible. And this is where I think that we are going with the AI assisted tools. And Keysight is in the forefront of these applications.
I wanna go back to your, thoughts about the infrastructure because we're in this funny place, and I'd like to hear from one or both of you on this, is that we're using AI to help us do the jobs, but then we need to make data centers and the chips that support us to, all the compute power and then there's power integrity problems and thermal problems and all of that. And we're doing it all at once. And I saw a really interesting short of someone walking through a data center with all like oil cooled, 8 NVIDIA GPUs on in one system. It was completely quiet. It was so space age, like you're saying, it's Star Trek. It looked like science fiction. So, what are the implications of that data center, and where are you guys positioned specifically around the data center? I mean, you talked about chiplets and those kind of things, so we can do it more in a modular or systems way. But um,
Yeah, this is a really good question. And we have a colleague at Keysight, Heidi Barnes, that she always says, "Don't forget power." She has this funny thing that says, "Don't forget power." And this is true because we don't always think about the power delivery and reliability, right? This is I think it back. We all
huge.
have to think about it, but the thing is, it, it's one of the most important parts of circuit design. And just to keep it simple, it's not just about power delivery and reliability, but it's really power integrity. You know, and then if you think about electronic devices, you think, oh, this is super low power. And then you think we started with 5 volts, and then if you look at the components that I mentioned before about the components of the compute units of the data center, the CPU, GPU, and so forth. A CPU today, a modern CPU uses anywhere from 1.3 to 1.8 volts. DDR 1.2, and the GPU is less than a volt. Well, it's super low voltage, right? But then think about that. This is a single complete unit. In a data center, you have
Exactly.
hundreds, thousands, right? So and then
Right.
I was kind of just back of the napkin type of calculation. And then if you think about if you multiply by 1,000, by hundreds, this kind of thing, we're talking about for the CPUs alone over 300 amps, and then for the DDR another 100 amps, and then GPUs, which you think, oh, less than a volt, but those are the ones that I was mentioning earlier on the AI dedicated chips. They are the ones that really crush the numbers for these large language models.
Mm-hmm.
So unless it's less than a volt, but by the thousands, it's over 600 amps. So we are talking thousands, like over 3,000 amps in a data
Yep.
center. You have to deliver this in a very reliable manner, consistent manner. And then when you get to these levels of power, then you think about the electromagnetic and thermal issues that can occur.
And signal issues and it
Exactly.
just
Yeah, it's
EMI, all of it. It just all stacks up. It really, in my mind,
it
not
is. It
being an
is.
engineer and not being Heidi or Steve Sandler, they did that. He created
Exactly.
that thing, the 2000 amp, refrigerated probes. And I'm like,
Yes.
what?
And it,
But did it, and used your tools to do
yeah.
it. So it's pretty
And I'll tell you
incredible.
one more thing, if the listeners, if our audience are interested, we have actually a really nice paper on Heidi did a really cool paper recently that we can put a link for people to
Yeah.
download later. But back to your question there. So then what we're doing here. So we are continuing to help the engineers to to have this single solution or platform, if you will, that can really tap into high-speed digital, RF, power integrity, signal integrity, chiplets, all in this single group of products, if you will. And for power integrity in 2025, we're bundling together. We are calling it the Power Integrity Designer Bundle. So then basically we're putting together our super well-known and really, really powerful product, PI Pro, Power Integrity Pro. We've
Mm-hmm.
conducted EMI, people also call it semi. So designers can have this complete end-to-end digital twin solution that covers the entire power delivery network design workflow, all the way from pre-layout, post-layout, and debug. And one thing I have to say is that one of the key differentiators of our solution is that because of our measurement expertise, we've been doing this for quite some
Mm-hmm.
time. Our solutions, they are super high quality. The high fidelity models that you can get for power analysis, it's amazing. It it's a huge advantage for designers to have such a tool for end to end the entire workflow. It's a time saver. It's really a time saver.
Yeah, well, before I really had gotten to know Keysight EDA, all the experts, Eric Bogatin, Steve Sandler, Heidi, all the signal integrity, the power integrity, EMI, everyone would say Keysight is the only one that has end to end. And many of them have taken the time to become a Keysight expert. That spoke volumes to me because that wasn't you talking about you. It was people using it on really challenging ways in the real world. So um, that's really what compelled me to want to learn more about the solutions you're providing is because people outside of Keysight just can't say enough good about it. But then also you're leaning into using this other parts of the technology stack like Ansys or Altium or whoever it is you're partnering with. So people, can regulate their own workflow. Richard, Roberto and I have been chatting way too much, which we could do all day long because we're both chatters. So I know that Roberto mentioned, and I'd heard from you that ADS, you're about to launch or you have launched, I don't know, the new your annual release of ADS. But what is Keysight EDA direction overall when it comes to AI and ML, going ahead from now into 2025?
Well, that's a great question. Especially with this product launch that we're in the middle of, we're integrating AI ML across device modeling, across RF circuit design. All of the groups that we work with are leveraging Python integration. But one of the things that's I think a measure of what we're able to offer at the moment is um, Keysight EDA recently won a bid with the U.S. Department of Commerce called AIDRFIC Design Enablement Program, which is a mouthful. But the AID part stands for Artificial Intelligence Driven RFICs. And it's the program group is called Natcast. And the aim of the program is to automate complex design tasks using AI driven tools. And what Natcast talked about in the webinar, which was the invitation for the bidders, was a real concern about workforce enablement as the technology becomes more and more complex. We're losing senior people as they start to retire who have 20 years of doing design experience, and we've got new people coming out of university that can't possibly ramp up that fast. So this is this project has an aim to help towards that, and there are specific project deliverables. The Keysight team in this project, which includes other partners, aims to make the AI enhanced workflow accessible to designers of all experience levels. So the definition from the program is by driving automation, optimization, and generation of advanced and unique RFIC designs, which is RFIC and Mimic, by the way.
Okay.
The project will improve the productivity and competitiveness of participating members in the U.S. semiconductor industry and also become a framework for innovation. So really what we're looking forward to is by participating in this project, Keysight EDA expects to help advance AI-driven technology, assisted engineering, as we've been talking about, which will directly benefit the state of RF circuit and system design in the medium term.
Yeah, it's funny because I've been doing this series on AI and design automation. I had the chance to go down to an advanced packaging materials company in San Diego and sit in on a semiconductor um, executive round table. But there was a presentation by a data analytics company that will help create that cohesion in the workflow too. So I'm just seeing this, from the government, from, it's coming at me at all sides, and it's really quite a view. And what you're saying just sort of ties everything up that I've been seeing with the bow on top, right? Is it leads to greater productivity. It helps engineers onboard faster. They still need to know how to engineer, but they get those core skills in college. So it's just so interesting to sort of see it half baked. And it's really exciting to see the things that the Keysight's doing and really leading the charge, which you guys kind of always have. So this has been a fascinating conversation. So, gentlemen, any last words before we wrap up? I know that you're very busy and I need to let you go, but any last thoughts before I let you go to wrap up?
Yeah, one thing I just want to make sure everyone knows about is we've got a launch event webinar on December 3rd that we would love everybody to register and come find out a whole lot more from our experts about what we're doing in these two areas. They can register for our live webinar on December 3rd to learn about the latest release. And if they can't watch it live on December 3rd, they should still register and watch it on demand. And we'll put links in the podcast here for you.
Great.
That they can access the demo videos, the app notes, and the white papers. We've got a page on our website that we call the What's New page, where we post all of the new stuff all in one place, and they can go check out all the new stuff on those What's New pages.
Great. Well, I'm going to get all those links from you for sure. And I will also share it not only with our podcast audience, but also on LinkedIn because this thing's moving so fast. And I think the work you're doing at Keysight EDA is fascinating. Well, anything from you, Roberto?
Yeah, no, I have one really quick thing to mention. There's one white paper that I wrote that is very interesting, and it's going to be on the page that Richard mentioned. It talks about how concurrent engineering it's helping fuel or accelerate AI adoption. It's a really fun ebook that we put out there. It's going to be on the page that Richard mentioned, and I want to invite everybody come see this special event we put together, EDA Keysight EDA 2025. It's a must-see event.
Well, again, thank you both for giving us a insider's view of everything you're working on, and I'll make sure I include all those links and resources for our audience. We will see you next time. Gentlemen, I hope you come back in the new year and give us more updates on what you're doing in this exciting area.
Okay, Judy, talk to you soon.
All right. Thank you, Judy.
See
Bye.
you soon. For our audience, thanks so much for joining us today. I trust you enjoyed this conversation with Richard Duvall and Roberto Piacentini. We'll see you next week. Until then, remember to always stay connected to the ecosystem.